Dear ladies, gentlemen, dear colleagues, bonjour, good morning, good afternoon, and good evening for some of us. Welcome to this side event, a French side event to the 65th General Conference of the IEA. This side event has been prepared by Andra, the French Radioactive Waste Management Agency, and will be dedicated to Cigéo Project, the Deep Geological Repository project in France. This project started 30 years ago, and we decided that it was a good opportunity to have a look over our shoulder on the past and to have a quite short vision of the next steps for Cigéo.
Welcome everybody. We are here in BOURRIAUX, and it's located where it's located most of the research facilities of Andra, including our underground research laboratory. And that's what we call the Centre Meuse-Haute-Marne, 250 kilometers east of Paris, where Cigéo might be built one day. I am Marie Maertens, Cooperation Manager at the International Affairs Department at Andra.
And I am Daniel Delort, the head of the International Affairs Department at Andra. So Marie, can you give us some few information about the organization of the side event, please?
Yes, we have interviewed selected colleagues to present you Andra activities, and with a special focus on Cigéo. We are going to spend 1 hour and a half together during this web conference. Your microphones have been turned off, and for technical reasons we have pre-recorded the interviews with our colleagues. So you're going to watch these interviews, and we invite you to ask all the questions you may have all along, either in the chat if you have a Gmail account, or via email. Send us an email with the email address you already have, the one with the link to this web conference. Because we are going to have a live session at the end of these interviews, and we will answer to all the questions you may have. So please ask all the questions you have. But before maybe we start to introduce our speakers, maybe Daniel, you can tell us about what is Cigéo.
Well, Cigéo in a nutshell, because it will be it will be described detailedly during all the sessions. So Cigéo is a French deep geological repository project for high-level waste, intermediate level waste. The repository will be located at about 500 meters depth in a clay layer of about 140 meters thickness. At the repository level, there will be 3 areas, 2 dedicated to the disposal of waste, one for high-level waste and the other one for intermediate level waste. In between these 2 areas, there is a central zone, support zone, which is connected to the surface via shafts for the support of the construction, operation, ventilation, maintenance of the facility, and by a ramp to another surface facility where package will be received, controlled, and packed condition for the final disposal. And so it will be presented in detail during this side event. And Marie, can you just give us a few details about the organization of the side event itself?
Yes, so we told you we have selected speakers. First we will discuss with our CEO, Mr. Abadie, who will tell us about the 30th anniversary of Andra. And then Emilia will come to explain us the tremendous work that has been done here in the underground research laboratory. Then Gérard will show us what is Cigéo today, what is the Cigéo design as it is today, and eventually we will discuss with Pascal, who will tell us where we are now and what are the next steps in the project.
So, a last reminder, if you have any question, please send it in the chat. And okay, let's get started.
Let's go.
Let's go. So let's start with this side event on Cigéo, and we will start with Mr. Abadie, the CEO of Andra. Good afternoon, Mr. Abadie.
Good afternoon, Daniel.
Good afternoon.
Good afternoon.
It is always a bit stressful to introduce a CEO, and especially when it is yours. So please, Mr. Abadie, can you introduce yourself?
My name is Pierre-Marie Abadie. I have been the CEO of Andra for now 7 years. Before I was the Director of Energy of the Ministry of Ecology and Energy.
Okay, thank you. Mr. Abadie, 30 years ago, France created the National Radioactive Waste Management Organization. How Andra is born? Can you tell us?
Well, actually, it's a long history, and there is even an history before Andra, because waste management has always been part of the French energy policy. And we started with a repository for waste management, for radioactive waste, for many decades in 1969. Then in the 80s, the government was facing a strong opposition to local investigation for a future deep geological repository. And they decided at that time a moratorium. They voted a new law and they created Andra as an independent agency, independent from the producers.
And can you briefly present Andra today, its role, its missions?
As I was saying, Andra is a public agency, 700 people located on 4 sites. The headquarters first in the Paris neighborhood. Then the first repository I was talking about, which is in the northwest of France, near the La Hague factory, reprocessing plant. Then 2 additional surface facilities in the department of Aube, taking in charge intermediate and low-level waste. And to finish, the underground laboratory located at the border between Meuse and Haute-Marne, and which will also be the location of our future deep geological repository.
Okay, thank you.
Moreover, about the main activities of Andra, we have 3 main activities: research and technological development first, then project management and design of new facilities second, and of course I was talking about a waste management repository operation as a nuclear operator for now many decades. And we are taking in charge all the waste coming from the industry, electronuclear industry, the defense sector, but also healthcare and research and many small activities all around the country. We have also some public service activity and missions, of course information, outreach and awareness, but also cleanup and depollution of polluted areas as soon as they are orphaned, and to finish, of course, outreach at international level and international cooperation. Dealing with all types of waste give us an experience, but also a responsibility to assist the French national government in their radioactive waste management policy. In France, the key document is the French National Radioactive Waste Management Plan, which is established under the responsibility of the Ministry of Energy, and it gives us our strategic framework for all our activities. And a new edition of this plan should be published in the next weeks.
Okay, thank you. Mr. Abadie, according to you, what are the key success factors of the French national waste management policy?
Well, from the beginning and already in the law of 1991, our waste management policy was relying on 2 pillars. One is strong institutions and governance, and the second one, it is a transparent roadmap with a very step-by-step approach with definite, precise milestone. As far as institutions are concerned, of course, the first one was to create Andra as an independent body and agency. But independent doesn't mean that we are not accountable. Of course, first of all, we are under supervision of the French government and the French Parliament, which was from the beginning very involved in this policy. Of course, we are under control of and supervisory of safety authorities, environmental authorities. But we are also accountable to French waste management producers, which are financing us, and under the principle of the polluter payer principle. And of course, we are also cross-examined by some specific commissions. I am thinking in particular of the French National Assessment Commission, which are high-ranking academics which are evaluating our research policy. And more generally, we are in an international network of peer reviews and cross-examination and benchmark.
Okay, and the second important point you mentioned was the roadmap.
The roadmap was really essential. And 30 years ago, it was defined in a very transparent manner. As you can see on the slide, it was a steady progress in the implementation of this roadmap with regular, I would say more every 4 or 5 years, milestone, with comprehensive reports, with a safety assessment at each time, international peer reviews, interaction with stakeholders and social societies through national debates and other consultation, and at the end, decision to be taken either by the government or by the parliament by a law. And there has been in this history 3 laws, and we know that in the next decade there will be other milestones with the parliament. This step-by-step approach was also relying and supported by an underground research laboratory since the year 2000. It was an evolving facility. We started with feasibility studies, then more site characterization, and then we moved to demonstration of concepts of cells, of galleries, and now we are progressively moving to more and more technical and technological issues linked to constructibility.
And Emilia will explain that to us as well.
Right. Okay, so we have seen this very clear roadmap. Mr. Abadie, can you give us some word about what is going on today at Andra?
For Cigéo, clearly we are entering in the permitting and licensing phase. It is a double-track process. On one side, we have very classical procedures and permits in environmental issues or for the declaration of public utility, which will be a key element to start the construction and the preliminary works necessary to the final construction of the facility. And in parallel, we will have the safety assessment based on a file that we will applicate next year in 2022, and which will be analyzed by the National Safety Authority.
Okay, so I understand that we are at a very important stage in the Cigéo project, and I have a straightforward question. Is it really necessary to build Cigéo today?
It's a very good question, because it has always been, and it can always be a temptation for the decision maker to postpone decision. And at the same time, it is also a common position of everybody that there is an ethical requirement not to transfer the burden of waste management to the next generation. And so we try to objectivize this ethical requirement with a social and economical assessment study. This study compares Cigéo with other options like postponing the construction with interim storage, and it takes into account incertitudes in terms of evolution of our societies, climate change, geopolitical turmoils, pandemic, and other disruption in the evolution and deployment of our society. And the conclusion is the added value of Cigéo today as an insurance for the future in relation with the risk of social degradation. This study has been counter-examined by economists, which confirmed the conclusion that it makes sense to start now the construction of Cigéo. What does it mean to start now the construction of Cigéo? It means relying on the skills and the abilities or capabilities of the nuclear industry now, but at the same time not to take all the decision and to remain some points open to take into account technological progress or evolution in the energy policy in the next decades.
Okay, thank you very much.
Thank you very much, Mr. Abadie.
So we invite you to write all the questions you may have in the chat for the live session that we're going to have at the end of this conference. Thank you.
Our second speaker joins us, and Mrs. Emilia HURET, to make a presentation of 20 years research here in BOURRIAUX. Hi, Emilia.
Hi, Daniel.
Hi, Emilia.
Hi, Marie.
So can you briefly present yourself?
Yes. I joined Andra in 2008 as a geologist. First, I work on the rock characterization and field investigation. For 3 years now, I work with 40 people to supervise all the scientific experiments in a lab.
Okay, so we are here in the Centre Meuse-Haute-Marne, next to the underground research laboratory, close to where Cigéo might be built one day. Can you tell us more about this place?
Yes, the Cigéo project, if it's authorized, will be located to the north of France. And you have a picture to represent this place, more precisely in the Meuse-Haute-Marne region, at the east of the France. There were no nuclear installations in this place. So why this place? In part because of its geology. On a geological point of view, we are in the east of the large sedimentary basin, the Paris Basin. This geology of this basin has been studied for a long time and is very well known by some geoscience academy. To be more accurate, the DGR, if it's authorized, will be built in a deep clay formation at about 450 meters depth. This layer, as you can see of the cross-section of the geological map, is called Caluvian-Oxfordian Formation. Is a rock of 160 million years old. The clay rock has many characteristics of interest for the implementation of a deep repository, such as its mineralogy, its hydraulic conductivity, its thickness of more 130 meters, and the simple geological regional context.
So on this cross-section, that's the blue layer, is that correct? Yes.
Yes.
And the URL is built in this Caluvian-Oxfordian formation?
Yes, that's correct. Following a call for volunteers, the French government approved the construction of the underground research laboratory at BOURRIAUX in 1998 to study in situ condition the rock formation. The construction started in 2000. Years after years, the underground facility evolved, but also the surface facilities. As you can see of this picture, the Meuse-Haute-Marne Center is made up from several facilities. To the front of this picture, you can see the permanent environmental observatory created in 2007 in an objective to better understand the evolution of the natural environment around the future Cigéo project. Inside this facility, there is an environmental specific bank to preserve all the environmental samples collected. To the right on this picture, you can see the Technology Center created in 2009.
And that's where we are right now.
Yes, and I have a video to show you the center and also to visit the URL. So the Technological Center, where we are, is a place open to many visitors to present the DGR project and also the radioactive waste management challenge. They are at scale, handling prototype as container, packaging, and also some successive generation prototype of pushing robot. At surface, the URL facility occupies 17 hectares. It includes working area and office, and also the two shafts to access to the underground facility. All underground activities are controlled from the surface by the command center. We are in contact all the time with the underground worker. And you can get down to the lab in 7 minutes. Today, the URL is a network of around 2,000 meters of gallery. We carry out scientific experiments to test and to study the rock, its behavior, drilling techniques, rock material interaction, and some technological demonstrators. Since the lab was set up, over 80 experiments and technological demonstrators have been initiated. And we have also 20,000 of sensors installed in the URL. We have a high-performance data acquisition and management system. We gather data remotely and monitor change in real time. Data and get read and sent to the surface and follow and analyzed by some scientists. Today, it's approximately 2.5 million of data recorded every day.
Okay. impressive. Well, I know that today here you are about 300 people working permanently.
Yeah.
Can you describe just quickly this community of workers?
It represents some scientific, engineers, operators, and many contractors.
Okay, so you told us about URL activities, but they are part of a bigger R&D program, which follows the Cigéo program and the milestones of the roadmap. Can you tell us a bit more about the milestones of the URL
Yes.
through its development?
The first milestone was set with the start of the construction of the underground research laboratory and the first in situ experiment realized in a URL, in an objective to confirm the properties of the Calovo-Oxfordian formation. In particular, some focus was done on the comportment of radionuclide, mechanical comportment of the rock. All these results contribute to the 2005 dossier to confirm the feasibility of the disposal principle and to define a zone of interest. From 2006, the number of experiments increased. It's a phase of the consolidation of knowledge. Our focus was done on host rock and material interaction. And also we realized the first high-level disposal microtunnel demonstrator and the first sailing experiment in galleries. All these results contribute in 2009 to refine a zone of interest for the final DGR location. The next stage, until 2019, was dedicated to test various construction options for digging, tunneling techniques, support and lining design. It supported the safety option report submitted in 2015. Since 2016, we are in the preparation of the industrialization of the project. Demonstrator as close as possible to the industrial reality of Cigéo. This work is in activity currently and will be included to the construction license application to be submitted soon.
So this is the fourth stage of development of the laboratory. Can you just tell us how it will be connected to the instruction of the license application?
Yes, we start a new phase in 2019 for 6 years in an objective to have 600 meters of drift excavated with associated to the major program of experiment. This experiment has the objective to be close to the industrial scale. For example, today we realize the digging of the first intermediate level waste disposal tunnel in a laboratory, and we prepare for the next year a major program of tests on the ceiling structure.
Okay, so the URL, is it used only for Cigéo Project, just for Andra?
No, our underground laboratory is an exceptional and the unique scientific tools. It contributes to the Andra expertise, which is internationally recognized and the most advanced in geological disposal in clay formation. Our international counterparts who focus on clay environment have a very close connection with us. For example, we have some consortium and partnerships, for example, with Switzerland or Belgium. But of course, we also interact with countries with projects in novel rock formation, and we can share our feedback on the construction and development of the URL. For example, we contribute to the URF network with the IAEA.
Okay, and well, the Underground Research Laboratory is also a training center, in fact.
Yes, URL can be also a training place for students and scientists, and we have welcomed a lot of French and international scientists here. But the URL and the other surface facility of the center are open to the public. Andra shares with everyone about the scientific thematic or about the project. For example, civil society or stakeholder.
Okay, thank you.
Great. Just can you give us a few words of what will be tomorrow? What are you going to do in this laboratory tomorrow?
Yes, what we discussed now, we are in a new phase until 2026. Andra will soon submit a license construction application file. All activity in the URL contribute to its instruction and the preparation of the industrial pilot phase, if the project is granted. And the main challenge are, first, to achieve a high industrial level of design, integrating technical and economic optimization, and also we have to consolidate the control of safety in operation and after closure with the continuation of some experiment. And for that, all the activity on the laboratory will continue over a decade.
Okay, thank you very much, Emilia. Thank you very much. So a lot was already achieved with the underground research laboratory, and so much is still to go on. Thank you very much. I hope you may have a lot of questions for Emilia, and Emilia will be joining us for the live session at the end of the session, pre-recorded session. So please write all the questions you may have in the chat. So the design of Cigéo has benefited from many experiments that have been done here in BOURRIAUX, in the R&D department. But what does Cigéo look like today? That's what we are going to ask Gérard BOURRIAUX right now.
Now we are welcoming our third speaker, Mr. Gérard BOURRIAUX, and for a presentation of well, what is Cigéo today, and is Cigéo in movie? Hi, how are you doing?
Fine, thank you.
Good afternoon, Gérard.
Good afternoon.
Gérard, can you introduce yourself in a few words?
Sure. Joining Andra in 2014, I am the head of studies, computer graphics and technical information systems. I belong to the engineering department. I am in charge of a team of 15 people to take care about all these activities.
Okay, Gérard, so we understand that Cigéo is a huge amount of information and data. So can you just explain us what is going on today with this data?
Okay. First of all, a general overview. Cigéo is composed of two surface facilities: a shaft zone for ventilation, equipment and material transfer, supplies and personnel, and a dispatch zone with a railway terminal and an access ramp. One underground facility with 60 kilometers of gallery at 500 meters below the surface in the indurated argillaceous layer, 650 hectares of infrastructures. The detailed engineering phase of the stepwise design of Cigéo have been completed at the beginning of 2021. Let's talk about the dispatch zone. The primary waste packages are transported from the producer to the dispatch zone by train. Two kinds of radioactive nuclear waste are managed by Cigéo: high-level waste, HLW, intermediate level, long-lived waste, HLW-ILW. A focus on intermediate level wastes. After different quality checks, they are placed into a disposal concrete container with a screwed lid. The containers have followed a strict qualification testing program, drop test, fire. The waste disposal containers are irradiant, and that's why they are placed in the shielded transfer casks. It ensures radio protection, requirement for their transfer into the underground infrastructure. The weight of the loaded heaviest shielded cask is about 100 tons. Packages are forklifted to reduce steel structure components into the containers.
Okay, fine. And what about high-level waste?
A focus now on high-level wastes. Primary packages are emplaced into steel overpack, and the lids are electron beam welded. When emplaced in the transfer cask, the payload is about 100 tons.
Okay, so how do you transfer these casks from surface to the underground facility?
Okay. Shielded casks are transferred from surface, the dispatch zone, to the underground infrastructures through a nuclear access ramp and a funicular. A structured multi-criteria analysis, including criteria such as safety, simplicity, robustness, gauge size, design feasibility, technological limitation, and obsolescence rates was carried out, involving experts external to the Cigéo project to choose such a technology. On surface, the ground level station includes a cask unloading area for cask transshipment between funicular vehicle and transfer shuttles. The ramp layout includes an inclined tunnel accessing to the underground station into the main support zone at the repository level. This zone is located between the disposal area for the intermediate level wastes and the high level wastes. It is also connected to the surface facility, the shaft zone, by shafts for maintenance, construction support, ventilation, personnel transfer.
Okay, so it's going down to a ramp in the tunnel. What are the dimensions of this tunnel?
Figures quite impressive. The diameter of the tunnel is about 7 meters. The depth of the tunnel is around 12%, and its length is about 5 kilometers. Today, we are testing a full scale of the funicular with a demonstrator of a depth of 12%. A testing program is planned to be completed by the end of 2022.
Okay, so let's imagine now the shielded casks are at the repository level in this central area. So what happened next?
From the underground station, casks are transported by shuttles on rail horizontally into access galleries towards high-level waste and intermediate level waste zones, and then a disposal cells. Shuttle engines are electrical to reduce the fire load.
What are the final operations for intermediate level waste?
First, for intermediate level wastes, the cask is deposited in front of the disposal gallery and then picked up by a docking shuttle to bring it to the cell door. After docking, the container is removed from the cask to be transferred in the cell head. Into the cell head, a specific handling equipment prepares the package for the final transfer to its definitive disposal position by an overhead crane. The opening of the different gates between the cell and the cask are synchronized to ensure safety requirements. Containers are stacked layers by layers to reduce consequences of drop risk up to the roof cell.
And can you tell us about the size and the diameter and length of these cells?
One more time, quite impressive. Diameter is 8.4 meters and for 500 meters long.
So that's the path for the intermediate level waste.
Right.
What about high level waste?
For the high level waste, for the underground station, casks are similarly transported by shuttle towards the dedicated cell. After docking, the radio protection plug is removed, and the waste package is transferred from the cask to the cell head by a push-pull chain. Before undocking, the transfer cask radio protection plug is put back to close the cell. A second equipment hosting a pushing robot is docked to the cell. Thanks to inflatable packers, it will push the package to its final disposal position. It is crammed back to the shuttle. The plug is positioned to secure the cell. After docking, this second equipment is stored into a gallery. During that time, the empty transfer cask is going back to get another package.
And I have again the question, how long, how big are these cells for high level waste?
1 meter in terms of diameter and 150 meters long.
Okay.
Right, Gérard. Well, I guess this is a very huge amount of information you have to manage. What did you implement inside Andra to organize all this?
Management data is a key process that needs to be addressed in advance. As you can imagine, such a project generates a huge amount of data in terms of volume and diversity. We decide to rely on two technologies, PLM and BIM-DM. First of all, the PLM, Product Lifecycle Management, in our case, Plant Lifecycle Management, allows us to manage, since 2014, data as documents, specifications, requirements, modification requests and follow-up processes, and ensure traceability and configuration management through a unique database. The PLM is a digital biography of installation throughout the project and installation whole life, from engineering phase to closure of the site.
So you mean digital biography? It means that to prepare reports or application file, you can extract all the relevant information that you need for these reports?
Yes, correct. We have the possibility to get the right level of reporting. For the official authorities about the completeness of the requirements, regulation, operational, engineering, for the deliverable delivery status also, and many others.
Okay.
And what about this building information management system or modeling?
The BIM methodology is based on the digital mock-up, has been developed to have a robust 3D representation of the facility. It allows us to run any kind of simulation, mechanical, thermal, seismic, to check the consistency of all systems. BIM relies on the exchange of information via multi-business and multiplayer digital mockups, and is the right support for project reviews. The different videos of this presentation are based on this mockup, so it is a precious support for communication.
And what will be the next direction you would have to manage?
We are going to continue developing these two technologies by adapting them to the next phases of the project, construction and operation of the industrial pilot phase of Cigéo. We plan continuing innovating to improve links between these technologies to achieve dynamic connections of the 3D mockup, the highly visual BIM digital model, and the data available at the level of the PLM. One of the main aims of this plan is to ease and improve collaboration between the multiplayers. It is an operational performance accelerator.
Okay, you are talking about multiplayer, so you mean that there's many people working with PLM and BIM?
That's right. With the next phase of the project, the number of contributors will increase drastically. Sharing requirements and specifications, collaborating on design, managing flows of control information in general will be of a paramount importance. Each change is integrated into an updated configuration of the entire model. It also allows to assess design modification impacts on requirements and simulate operations. This helps to improve the quality and performance of the system. Matching PLM and BIM technology is by itself a challenge that we are confident to achieve. It will be an element of success of the next phase of Cigéo, an innovative and ambitious approach for the benefit of all the actors of an exceptional project.
Thank you very much, Gérard. Very impressive.
You're welcome.
Yeah, a big thanks. So, as a reminder, there is a chat. If you want to ask a question, please do not hesitate to write them, and we will try to answer to this question at the end of this session today. So, as you have seen, Cigéo is not only a scientific challenge or an engineering challenge, but there are also other challenges. And for this, we will ask a last speaker to talk about, Mr. Pascal LEVERD, and he will tell you what is going on today with the licensing process and the future of this facility. Now our fourth and last speaker joins us, Mr. Pascal LEVERD, and the last talk is about what is going on today with Cigéo. Good afternoon, Pascal.
Good afternoon, Daniel.
Good afternoon, Pascal. Pascal, can you introduce yourself in a few words?
Good afternoon, Mary. Yes, gladly I will introduce myself. I've been working for Andra, for the Cigéo Project for the last 10 years. I am now the deputy of the director of the Cigéo Project. In recent days, I've been more involved in the preparation of authorization files of all kinds and with interfaces with public and the society.
So, can you tell us what is happening today with the Cigéo project? What is going on in the kitchen?
What comes on short notice is the process that should lead to the declaration of public utility of the project. It started more than a year ago with the submission of a very large file containing the technical description of the project, the socio-economic assessment, and the justification documents of the project. It also contained a very important and very large document, the environmental impact assessment of Cigéo, covering all the periods and all the dimensions of the project. The file has now been reviewed by the state authorities, and it is time for the public to give its say. In fact, the public inquiry started last week. Last Wednesday, it is a big public exercise organized on a large territory of more than 100 communities. The Prime Minister could approve the declaration of public utility of Cigéo in 2022. Andra would then initiate several different authorization procedures. The most important one is the construction license application for the nuclear facility. We are in the process of finalizing this file, and we intend to submit it next year in 2022. Provided the license is granted, the construction works of the nuclear facility should start around 2026. We will also gradually submit all the on-site and off-site authorization permits for the preparative works. For example, the power and road connection or the construction of the administrative buildings. You see, the project is really going forward and we're thinking ahead. We're trying to imagine the first years after the construction license is granted, a period that we call the industrial pilot phase.
That's a word we heard already, industrial pilot phase. Can you detail what it is?
Yes. The project will last more than 100 years and will develop gradually, calling for future successive decision steps and authorization procedures. Following the public debate of 2013, Andra proposed an industrial pilot phase at the beginning of the project. In 2016, the Parliament took up these proposals and made it into law. The objectives of the industrial pilot phase are twofold. It aims at gaining technical and organizational experience in the facility, and also on the more societal side, at putting in practice the collective governance scheme that is currently under development. On the technical point of view, the pilot phase serves to collect geological and environmental data. First, it is used to confirm, under real underground and operational conditions, the parameters and data that were introduced in the design of the facility and in its safety demonstration. It is also used to gradually take charge of the industrial facility, to start the disposal operations, the monitoring of the facility, and to gain the first lessons from it. Various testing programs will be carried out, in particular on retrievability. Retrievability is the ability to retrieve a waste package from the facility after it had been placed in the repository, should future generations reconsider the disposal decisions that was taken. At the same time, the industrial pilot phase is the time to establish and gain practice in the governance process. Governance, in other words, is the way the decisions concerning Cigéo are prepared and followed in association with members of the public. It offers all stakeholders and the public the possibility to participate in the project and to be involved in the big decisions. For example, the decision to start the disposal of nuclear waste packages or the program of facility modifications. You see, the industrial pilot phase really materializes the cautious and progressive deployment of the project. The industrial pilot phase will begin after the construction license is granted. It will last for 15 to 25 years, depending on the rhythm of construction and on the result of the testing programs. It will come to an end according to a decision taken by the Parliament. Andra will produce a report presenting the lessons learned from the industrial pilot phase, and once this report has been assessed, the Parliament will decide whether or not to continue the deployment of the project and the conditions for this. The definition of the industrial pilot phase and of the governance scheme is currently the subject of public consultation. Andra will use the result of this public consultation to finalize the proposals that will be presented in next year's construction license application file.
But, well, to be clear, these last 2 years with this pandemic situation, how did you manage this consultation, public debate, public consultation?
Of course, during the crisis, the public meeting were to be avoided as much as possible, and for the last year and a half, we had absolutely no visibility to program our encounters with the public. So we decided to make the largest possible use of new digital means. The material for the consultations is fully published and fully accessible to all on our website. We have a platform where we collect comments and where we answer questions. We use social media for the promotion of our digital events. And we organize web conference just like this one. I tell you what, these new means, new digital means, they also have advantages. They reach new people that would otherwise not have turned up to more classical meetings organized in the local venue. They produce orderly discussions and create efficient exchange of information and answer to questions. And I think that's what we're going to do after my presentation.
Okay, so, you said several times that, this project will last a long period of time, 100 years, 120 years. Well, I guess there are other challenges linked to that duration, like knowledge management, memory preservation.
Yes, working for Cigéo is really working for the future. You're working for future generation. Actually, you can see yourself as a future ancestor. And to be a good ancestor, you have to pass your knowledge to the next generation. That's what good ancestors do. So Andra engaged in a full knowledge management plan involving critical knowledge assessment, capitalization, sharing, and innovation. In practice, it implies work with our human resource department to organize the flow of knowledge between generations of employees, especially the knowledge and practice held by soon-to-leave colleagues at the occasion of their retirement. It is particularly useful to document, explain, and justify choices on the long term. Within the organization, we foster continuous learning process and communities of practices centered on very practical issues, for example, safety or the knowledge of waste package content. We participate to international practice, international activities and working groups on the matter, within EDRAM, for example, the NEA or the IAA. We have the ambition to become really what we call a learning company.
Okay, and what about the memory preservation? How do you work on that?
Andra launched its program called Memory for Future Generation in 2010. On the institutional side, it relies mainly on fulfilling regulatory requirements regarding archives. The Manche Surface Repository, operated from 1969 to 1994 and now in the closure phase, is a pilot for memory provisions. The official key information file for this surface repository has been issued. It is now part of the summary memory file that is required by the regulation when entering the closure phase. On the societal side, it aims at fostering awareness of the presence of the disposal sites. We organize art contests around the subject of memory. We support local resident groups near each facility. A big part of the program is made of R&D on natural science, for example, durable material to carry the information, and also on social science, like semiotics, history, or lessons learned from the past. At the international level, we participate to the common effort and initiative to advance toward a global umbrella level for memory provisions. So you see, even provisions for the long term can really be part of the hot topics.
Yeah. Indeed, thank you, Pascal, thank you very much. So Pascal is going to stay with us for the question and answer session, the live session that we're going to have just afterwards. So I hope that you have a lot of questions and I hope you wrote down in the chat. Thank you. Welcome back for this live session. As we said that we are back in BOURRIAUX to answer all the questions you sent us. We have with us Daniel Delort and Pascal LEVERD. Thank you very much for all the questions you sent us. And maybe I can start with the first one. Maybe to you, Pascal, there's a question saying, why is there two tracks in the application, one called the Declaration of Public Utility and the other one the Construction License Application? Can you explain us these two tracks?
Well, these separate tracks are the result of the French regulation. First, you have the Declaration of Public Utility. It is somehow the condition for the other authorization. It enables the urbanistic development plan modification. It also helps for land acquisition. It is a kind of go for further authorization. And then you have the construction license application that is really focused on the nuclear part of the facility. It will be assessed mainly by our National Safety Authority, and it contains the detailed safety demonstration for the operational period and also for long term. Aside of that, you have all the on-site and off-site permitting, all the preparation works that have to be carried out, for example, for road modification or power supply. And this is not specific to nuclear. These are authorizations that would have to be followed for any kind of project.
Okay, thank you, Pascal. Please.
Yeah, there is a second question, and I'm sure, well, maybe Pascal, you can take it. The social economical analysis, what is it?
Well,
So
I will try to make a long story short.
Yes.
But it's a very interesting point because it was the first time that we carried out this kind of exercise, a socio-economical study of Cigéo. Basically, it is a study made by economists to objectivate the interest of our project. It is a comparison between Cigéo and other options of waste management, including not building Cigéo, continuing to have interim storage repeatedly, and to take into account the long term, it has to compare different kind of situations. Why different kind of situations? Because in economics, you have to use what is called capitalization rate or discount rate, which is basically the growth of our society. And if it is positive, then the future generation will be richer than we are. And if it is negative, then we are richer than future generation. And you have to take this into account. Basically, why should the poor people of now pay for the rich people of tomorrow if you have positive interest rates? And to compare this fact, this evolution, you have to imagine various scenarios of the future society, whether it is stable or whether it can turn into a more chaotic state. In a stable society, interim storage is more interesting than a repository than disposal. But if the interest rates aren't growing forever, then immediately disposal turns out to be more interesting than repeated interim storage. So it is really an objectivation that a repository is a form of insurance. Basically, you pay now, but it is not to pay more later. And it's very interesting because it is the first time that really the interest for the future generation was put into words and into figures. Basically, what you have to remember, the conclusion of this study is that in any case where the society would turn to a more chaotic state, if you care for the safety of future generation, then a repository is the best solution for the society. And you have to know that the result of this study by Andra was also analyzed and assessed by independent experts from the government, and they confirmed our conclusion.
Okay, thank you, Pascal. The next question is about geology, and it's: do you think that clay rock is the best rock, best suitable for deep geological repository? Maybe Daniel?
Well, I will try. This question is coming very often, in fact. Does clay is preferable to granite, to salt, to things like this? In fact, we don't have the answer to this question because, well, repository, it's a concept involving a rock mass, but also engineering barriers and multi-barrier systems. Then the efficiency of the disposal system is based on the performance and the contribution of the safety performance of each of these components. For clay layer, clearly the rock mass play an important role in the long-term safety of the repository. But for other concepts in granite, this safety performance is brought by engineered barrier, and the geology provides stable condition to this engineering barrier. In salt, the specificity of the salt, has by itself intrinsic properties that help to fulfill the safety requirement. So it's very difficult to answer to this question, what is the best rock for a deep geological repository, because you cannot split a concept in part and saying that is better and this is better. It is the overall concept that has to be assessed and has to fulfill requirements, safety requirements.
Okay, thank you. Maybe we can have the next question, please. Okay, that's a question of how much costs Cigéo. That's a question. Maybe
It's also a question that we have often. So the cost estimation for Cigéo is 25 billion euros, calculated on Euro 2014. This cost includes the cost of studies, the cost of construction, the cost of operation, taxes, the cost of dismantling the facility and closing this facility. So of course, it includes a lot of operation where there are uncertainties, and this is why the French regulation asks Andra to reassess periodically the cost of Cigéo. So the last time was in 2014, and we will assess the cost of Cigéo again after the construction license application is transmitted next year.
Okay, thank you.
Well, I didn't say we are going to assess it next year, but after we transmit the license application next year. So it'll probably around 2023, 2024.
Okay, thank you very much. The next question is about the Cigéo, the design of Cigéo, and the choice of a funicular. Why did Andra decide to get the package down via a funicular? Do you have?
Yeah, well, I guess it is funicular against shafts. Well, in fact, this decision was very progressive, and we make it step by step. There was an original expectation is to have facilities in the two districts where we are today, one in the Meuse and the other one in the Haute-Marne. And there was also this concern, this feeling of the public during the public debate following the 2005, where for the public it was the reversibility and retrievability was easier to understand when you have a tunnel, a direct access to the repository, not through a shaft. So progressively we moved to an access by shaft to an access by a ramp, and to make the transfer in that ramp, we prefer to use equipments with no inflammable materials, like trucks. So we decide to move progressively to a system with all the engines remoted on surface, and it was the funicular. Hopefully, the funicular was quite well known and well used, and we progressively moved to this solution. We detect all the element of the funicular that would need to be upgraded for the payload we want to transfer, to nuclearize this equipment, and progressively we went to a very specific funicular, and this is what we are defending today in our file. But the decision was very progressive. There was not a new day where we changed drastically the orientation of the project. It was really step by step, and we have tried to justify. Gérard told you that we went through multi-criteria analysis. It took time, but since 2009 we have this concept of a funicular, and we go into the detailed development of this funicular since 2011.
Maybe one more thing that you can say about the funicular is that a funicular with a ramp of around 10% is rather easy to maintain for the personnel on the ground, well, under the ground actually. They can make intervention on the funicular without carrying special equipment because 10%, 11%, 12% is considered acceptable for ordinary work.
Yes, absolutely. Thank you.
Okay, we have a comment about the fact that retrievability has been incorporated and presented by you, Pascal. Can you tell us again what does it mean, retrievability, in the Cigéo project and the industrial phase?
Well, retrievability is one of the requirements now of Cigéo. Cigéo is designed and will be operated to keep it possible for the waste that was placed in the repository to be retrieved from the cells and taken back to surface for all the duration of the operation.
So 100 years?
Well, of course, more than 100 years. Of course, if future generations decide to close part of the vault or part of the repository zones, it would make it much more difficult to reopen these parts of the repository, to re-equip them, renuclearize them, and retrieve the waste. But presently, it is designed to permit all choices to the future generation, whether to keep it completely open and very retrievable, or close it gradually and decrease the retrievability of the waste.
Okay, thank you. We have now a question about the calendars. We have discussed that the declaration of public utility has been deposited last year, and the construction license application will be probably next year. And then when are we expecting any answers or development once this is done?
Yes, we transmitted the file for the public utility declaration in the summer 2020, and we're expecting an answer from the government early next year.
Okay.
So in the first trimester.
And what about the declaration, the license application? It will be submitted next year, and how long will it take to get an answer? Do we have an idea?
Well, that depends on the rhythm of the safety assessment, of the exchanging, of the depth of the exchanges, and that will happen between the safety authority and Andra, and all the questions that will be asked, and maybe the file modification. But we are foreseeing if this process goes along the track, that we could have the authorization for construction of Cigéo after 3 to 5 years of instruction, meaning between 2025 2027.
Okay, thank you. Maybe we can get the next question, please. Yes, that's a good question. During this industrial pilot phase of Cigéo, you will test, in fact, the project, I mean the repository, but really, when does the first radioactive waste package will get down?
Well, I can't tell you the exact day of the week, but it is foreseen to be received around 2035 or 2040, depending on when we have our construction license and on the operational rhythm of construction and the result of the first essay that will be carried out without radioactive materials. So depending on that, we imagine between 10 and 15 years of construction and essays. So That's why we have a 5-year uncertainty in the first waste package that will be disposed of.
Okay, thank you. Okay, so we have the next questions about the pilot phase again. So we consider that to last 15 to 25 years before the disposal waste can really proceed in an operation license. It means we discussed that just right now. First, you're going to test it with non-radioactive package, is that right? And then in 2035, we can start operation with radioactive?
When we say between 15 and 25 years, these two durations include disposal operation. It's just that the 15 years is a bit optimistic based on 10 years of construction and trials and 5 years of operation. And the 25 years is a bit more pessimistic based on 15 years of construction and trials and 10 years of disposal operation. But you really have to understand that in order to be able to go in front of the Parliament and explain whether or not this facility works, provides the industrial service, is safe, we need some real operation. We need the real thing. We cannot just say it works on the basis of just trials. So the teaching of real operations is also very important in order to go forward and to present the result to the Parliament.
Okay. Maybe Daniel, you can ask the next questions.
There was a previous one. Are there any specific R&D challenges when planning a repository for different types of radioactive waste, high level, intermediate level waste in the same zone? I would say yes. There are specific challenges. You have operational and construction challenges, but also you have to take care that there will not be interference between the two areas. For high-level waste, they are highly emitting heat emitters. So when we separate the two areas, it was really with the intention to isolate the intermediate level waste from the impact of this intrusion of heat emitters waste, which are the vitrified waste. So yes, there are specific challenges, but while this has been integrated since the beginning into our concept and the way we designed the facility. Since the beginning, we got these two types of waste to manage in a single repository. So. I'm sure, there were specific challenges. If another country planned to dispose these two families of waste or other waste in the same underground facility, there will be this kind of very specific challenges that has to be assessed as well and evaluated.
And they're completely separated in the repository. They're disposed of in separated zones. So it's like a house, they have the same entry, but then they have two separate rooms where they go to. And these rooms are separated by hundreds and hundreds of meters.
Yes. So
they're isolated.
Yeah,
physically isolated.
Physically in the clay rock layer. Yeah. How is the repository going to be marked on a surface in order to prevent human intrusion in this place in the far future?
That's another challenge that we have to face.
That's related to your topic on the knowledge management.
It's a very good question, but the answer is very simple. We don't know yet.
Yes, absolutely.
You see, memory provisions are something that are going to be constructed and to be finalized progressively. We have ideas, we have suggestions, we have provisions that are possible, but the way it's going to be marked is something that is completely open. There will be a building, a specific building in Cigéo called the Memory Building that is going to be designed to start playing a role, to be identified in the territory But as we were seeing in the presentation, the closure of Cigéo is foreseen in 2150. Probably this date will move. Maybe it will be closed before. Maybe it will be closed after. We don't know exactly. And how the future generation are going to decide to market on surface, we don't know yet. What is really important to know is that memory is important for safety, but Cigéo is safe even if it is forgotten because of this very important provision of our underground repository, which is passive safety on the long term.
And just as a reminder, in the siting process of the repository, it was clearly, and it was in our basic safety rules, to find a location where there was no potential economical interest to drill, to do something. So this site here was also chosen because there is no specific economical interest to go underground in this site. So, when you say marking the site, this is already in a track of solutions. The first reflection on this possibility and this risk was integrated since the beginning of the siting of this facility. But as Pascal said, everything we don't have to decide everything today, but we have to implement this dynamic on the memory preservation. What kind of information we want to maintain for the available for the future generation. But we can be sure today that the final decision on that specific point has to remind to the future generation. They will take this decision.
Yes, maybe one last word on memory. We recently organized a citizen conference on the industrial pilot phase, and it was one of the conclusions of the citizens to put in place the memory provision as early as possible.
Absolutely.
And it proves that it is a subject that has really an impact and that is really catching the attention of the public.
Okay, so that's really still an open question, but we are working on it. The next question is back to the license application. I'm reading it. Is it correct that there will also be an environmental impact assessment for the construction license application, as we had already for the first declaration of public utility?
Yes, it is true. The environmental impact assessment is an iterative work. The more precise, technically precise the project is getting, the more you have to reassess its environmental impact and make it more precise. Also, with the first permitting, the authority will emit new requirements, new monitoring methods, new actions for the preservation of biodiversity, for example, or for the preservation of the water resources. And all these action plans will yield results that will have to be reintroduced in the iterative environmental assessment. So, in fact, we're on the verge of producing many versions of this environmental impact assessment, and probably a few versions in the coming years, maybe 2 or 3, I don't know exactly. But anyway, there will be one for the construction license application, and also there will be others for the various permitting.
Okay, thank you. The next question is about the Cigéo design. I'm going to read it. Which kind of buffer and sealing materials will be used for Cigéo repository compartment sealing? Maybe Daniel, you can answer this question.
Well, there will be seals in Cigéo when it will be closed. Our intention is to try to reuse as much as we can the clay we excavate from at the time of the construction, and we will try to preserve this clay for future use. But we will have also seals in the facility based on the bentonite, mix of sand bentonite, and with concrete plugs to allow the increase of the pressure of the core of the seals. So, well, I think there is nothing really specific to our design, except that we will reuse we will try to reuse as much as we can the clay we excavate from Cigéo. I think this is it.
Maybe one thing we can say is that within the program of the industrial pilot phase, we will build several closure demonstrators, specifically one at the bottom of the ramp, because a plug in a tunnel with a ramp is something that we want to test very specifically. Also one for galleries and one for several disposal shafts. So there will be some demonstrators operated, constructed and tested during the industrial pilot phase, and I think it is also something that the Parliament will take care of. You know, you open something and you want to know and you want to prove that you know how to close it.
Absolutely.
And these essays that we will do during the pilot phase, they will be complementary to all that we've already done here at the lab, here in this room, or with all our international programs that we have participated to.
Okay, the next question asks about the capacity of Cigéo to hold high-level waste, means years of waste generation. So I understand what is the capacity of Cigéo to welcome the nuclear waste, and can we expand it?
I think it's a question about the inventory.
Yes,
the inventory is calculated with the hypothesis that the nuclear reactors will work for 50 years, will produce electricity for 50 years, for 50 years. Mm-hmm. And of course some are older than others, so it is a calculation of the waste production of the entire fleet of reactors that France has. Yes, there is some flexibility if there were more to dispose of or less to dispose of course. This flexibility or adaptability, it depends exactly what you are studying, is carried out by Andra. And we have presented results of the flexibility of inventory in 2005, 2016, and again we will present the flexibility of the facility in the construction license application file.
Okay, we have the next question. I don't know if you...
Well,
I can read it. Sorry, because we've seen it on the screen. Sorry. Did the movie Into Eternity about Oncalo repository had an impact on public image on Andra work?
I don't know. You will answer better to that question than me, but I think it was a very good movie. And
yes, for sure. This movie. I have no comment on this movie, but this movie got a certain echo in France, and and it has been given, let's say, a new topic of discussion with let's say, opponents and things like this, people like this. But anyhow, Andra, we are a public agency. I mean, we are public servants. I mean, we don't sell anything. So every component, every opinion on the solution we are proposing for this long-term management, even if it is controversial, if people doesn't agree, we have to integrate this. So yes, this Oncalo movie got an impact in our discussion with the public. And as a result, I have to say that today we don't talk too much about this movie It has passed through. Some question has been discussed, and the consultation, the dialogue is continuing. We didn't stop at this event. You want to add something, maybe? No? Okay. Okay, so, well, thanks for all these questions. I see that you are very interested. My feeling is this last steps of Cigéo with the licensing, with the question on this social economical study, the DUB, the DAC, what will be the process, what will be the next step. Well, for me, it's a real pleasure to have this kind of question, meaning that you are really interested in following what we are doing here in France, and we, as you know, we will be happy to share knowledge. We have a website, Andra, international.andra.fr, where we try to post news on this regularly news on this project. And we invite you to follow us, and we will be happy to answer to questions you may want to ask on our website. Maybe a few last words.
Yes, I'm afraid this is the end of this web conference. Thank you, Pascal and Daniel, for answering the questions. As Daniel said, we have a website, and if you did not get the answer, or if you have more questions to ask us, please feel free to get in touch with us through the website or on our email, and we will be very happy to answer you. And Daniel,
and yes, well, Mary and me, anyhow, we will be at the international conference of the IEA in November on radioactive waste management, a sustainable solution for the future. And so we will be very pleased to continue discussion with you, but this time with a coffee at the end. Bye-bye.
So, thank you very much. Goodbye.
Bye.